Okay, so I just handed out to you not only the homework problems for charge options and the likelihood, but also all the big issues, because those have been evolving over the term. So if you don't have all your big issue problems you want turned in, and I'm not sure anyone does, so you're not behind, then now they're all written down. You don't have to actually get to a computer or turn on your phone to see them. The charge options, just a heads up, it's a fill in the blank thing. So that table, it says S91. Excuse me. That means on the codes, that's where you'll put which bubble to pick for number 91 and so on. Okay. Anything else about this? Let's do other announcement-y stuff real quick. So one thing is the syllabus. So here's our calendar. This is the last day we'll do new things, probably. If you have lots of questions, we can certainly not finish today, but I expect we will. And all of Thursday, we'll work on big problems together and do review and things like that. It's not going to be another practice final kind of structured review, but I will probably print out some practice finals with answer keys like I did on the day of the midterm, just so that if you are sitting there twiddling your thumbs, I will say, great, let's all do this one together. But anyway, bring lots of questions on Thursday. This coming week, I am actually going to be gone on the 10th. My wife has a work conference in Boston, and I have relatives in Boston that want to see our kids, so the whole family is going to Boston. So I will be coming back Tuesday night, but I will not be here when you are in this room taking the final. Someone else will be proctoring the final for you. So that's on Tuesday. It starts at the same time as always, and then it goes longer than a class. Yes?
If we've already done the final, do we need to show up for it?
No, you can just run away. The grades are due the Tuesday after that, on the 17th. So what I always tell students is anything you have turned in at least once by the final, the last day that we're actually supposed to be together, you can resubmit things for the rest of the week. So whether it's a homework code, or whether it's a book report that you didn't quite answer fully, or whether it's a big problem that for some reason wasn't quite up to standards, whatever, if you've turned it in this week or on the day of the final, then you can have some chance to fix things. So at least try. Get all the stuff you want. If you're aiming for an A but not sure you're going to make it, then at least turn in enough things to earn an A by Tuesday. If you're aiming for a B, turn in enough things to get the B by Tuesday. And even if they're not great, then you can keep fixing them over the week. For some of you, that's a great thing because finals week clears up pretty quick, and compared to the rest of the term, it's like vacation is starting, and others of you, no, finals week is really busy. That doesn't help me at all. So, oh well, but that's the best I can do. And if you need me to have some sort of office hours or so on, then this building gets pretty empty pretty quick. So we could certainly say Thursday, let's all just sort of gather here at noon as if it was a class and whatever. But I've never actually had anyone schedule something that formal. But the offer is out there if it makes you happy. So this is also the last 2 days if you wanted to get the class participation achievements for doing stuff on the board and so on, then get them done. I think there's only one person that's aiming to get all 9 of those done that hasn't yet. So if you're not aiming for the plus, then you don't have to try and crowd that all in. Okay. Other announcement-y things. I'll do this again, but it's worth doing twice. If we go to the practice final, then the table with the fill in the blanks has easier blanks than on your homework. So we'll get to why this is easier, but this is something that's not as scary as it looks. You might think, for number 36, I should skip that because I have to do all of the stuff for one problem, but it's actually an easier one. So just a heads up, if I skip that later on, I might need to go back and show you that. Okay, other questions about things? What questions?
80, oh, I'm sorry, but I'm just not hitting 80 on the saving for retirement. I know that I don't understand that.
Okay, I'm going to make it a little bigger.
So, therefore, I'm not getting the answer right.
Okay. Yes, so you know it's rule of 72. Let's talk about that. Okay, so the rule of 72, if you can read that little chart, if not, let me know and I'll zoom in on it on the other screen bigger, says that if I take two numbers, they'll multiply to 72. And those two numbers are, one of them on this side, how many years have gone by since I put my money in the investment. And the other is what percent interest rate I'm getting. Not rip-flop, but as a whole number. So if I have a 3%, then since 3 times 24 is 72-ish, then I'll double my money in 24 years. If I have 6%, 6 times 12 is 72-ish, so 20,000. Happens in 12 years instead of 24. If it's 12%, then it would be 6. 12 times 6 is 72. So there's a few things. One, you would sort of guess that if you doubled the rate, your money would double twice as fast. And this is confirming that yes, that happens. It's also true that the time to double your money doesn't change. If it took 6 years to double once, since you're not changing the rate, it's going to take 6 years to double again. If it takes only, 24, if it takes 6 years to double once, 6 years double again, 6 years double again, and so on. Yeah.
So, because 7 times 10 is almost 72.
Yeah, if there was a 10%, it would be about 7 years. If there was a 7%, it would be about 10 years. And the 72 is approximate. It comes from logarithms. We don't care why it works. The other thing is that this doubling works for things other than money. Anything that takes 6 years to double, anything that increases at 12% will double in 6 years, whether it's how many bacteria or something, or money or whatever. Bacteria would probably be days, not years. But anyway, so let's go back to this problem. There's a computer game, and we don't need to know anything about this computer game or what's happening in it. We just have to know that there's something that gets 10% stronger at every level. So how many levels would it take to double and be twice as strong? It's 10% each time.
That's where I did 72.
Yeah, so about 7 times, right?
Okay.
So you'd expect that, knowing nothing at all, this is kind of amazing. I don't know anything about what an archer queen is, or what level 20 means, or anything like that. But since it's changing at 10% each time, after 7 times it will get twice as big, roughly. So, one brother has a level 20, the other brother has a level 27. Has it gotten bigger 7 times? Yes. So it's twice as strong. And that's an intermediate. We don't know anything about what strong means. We don't know what these little creatures are like in the game. But this information alone can say that this one is twice as strong as that one, because it's gotten 10% stronger.
Well, I get that part, but the answers on the assignment isn't that it doubled. It's a number. It's a percent.
Okay, let's go look and see.
I think it's 200. I think
And so that's where I'm getting.
Okay, because 200% is doubled. That might just be worded funny.
Okay.
So let's go look at that.
That's my question. So, like, 200% mean double it, or would that be?
So roughly how much, yeah, so 200% is double. Because 100% is all of it, and then another 100% is,
And that's where I was getting confused.
okay,
I
there we
kept
go.
ending up with 74%, and that's not right. So, okay. That makes sense now.
There's a similar one on the margin and markup where in 87, here we go, right? Actually, I'm going to highlight just that part and make a picture of it. So what's happening here is you're going to have two amounts of margin, how much more they sell it for than the wholesale cost is. And one of them is going to be 184% of the other. So that means that the bigger one is 84% more. There's the 100% that's sort of the smaller one, and then 80% more than that is what is the bigger one. So I could have put like 184% of the smaller, but I was bad and put 84% more, but they mean the same thing.
Okay. Thank you. That makes a lot better sense than, because like I said, I kept coming out, why do I keep coming up with 74%? That's not right. Okay.
Okay, good question. Other questions? Okay. So, new things then. Okay, we aren't actually quite done with pricing. We needed to talk about discount still. And discount has an easy problem and a hard problem with it. The easy problem is just using the 1 minus trick. So, a toy is selling for $80. We're going to put it on sale at 15% off. What is the discounted price? I could do this with 2 steps. And if you like doing it with 2 steps, that's not a problem at all. So I'm going to do it both ways actually. So here's 2 steps. Here's 1 step. So if I was doing 2 steps, I could say, what is 15% of 80? I'm actually going to save that just because it's so. Yeah, 10% of 80 is 8. Half of that again would be 4 more, so we'd get 12. Then so that's how much the sale amount was, the discount, right? We have to take that away. And we say, so the actual sale price is 68. Everyone okay with my 2 steps? If you like that, great. There's nothing wrong with it. You have enough time on the test. It's like 3 minutes a problem if you work it out. So we're okay. If you want to be quicker, then you would take the 80, and instead of multiplying it by a 0.15, we would multiply it by 1 minus, whoops, not the dollar sign, the 0.15. And this is similar to what you talked about with the Archer Queen 200% thing. We have the 1, and we have a minus 0.15. The 1 is this 80, because the 1 times 80 is still 80. And then the minus is this part, taking away the 0.15 times it. So if we did that, we would get our 68 without having to do first a multiplying step and then a subtracting step.
So am I doing it wrong if because how I figured it out was 80 times 15%, which is 12, and then I subtracted 12 from 80.
No, that's just the 2-step way that we did, right? So nothing wrong there. So if you like the 1 minus trick, if you're the kind of person that thinks margin instead of markup, then this is a nice way to do it. If you like the 2 steps, that's good too. Yes?
I should have asked earlier, but if you have time, can you go over the penetration versus the other terminology?
Sure. Yeah. I don't know if there's a problem on the final about it, so I'm not going to give it much
Is
priority.
it on our homework?
I think so, but I don't know.
It's on MathNet somewhere though. I can read it, right?
Yeah, and after class I'll do it.
Thank you.
Do you have to run anywhere? Okay, so that's the easy kind of discount problem. There's a discount. Here's the rate of the discount. Find either the dollar amount of the discount or, more commonly, find the sale price. They could ask you either one. The complicated one is the chain discount. The chain discount is where there's more than one discount happening. And here we'll have to do several steps. So the toy is on sale. First it goes 15% off, then it goes 20% off, and then it goes 10% off. All of those on top of each other. And this is kind of thinking like compound interest. I can't just add up the 15 and the 20 and 10, because that 10 isn't 10% off 100. It's 10% off some smaller amount that's been reduced twice already. And the 10% of a smaller amount is going to be a smaller number. So, just like in compound interest, there was the annual effective interest rate, sort of what's the overall effect of this, then this is a similar thing. I can't just add them up. There's something more complicated happening. I can do this in lots of steps. There's nothing wrong with that, except I'm not going to waste time in class writing them all out. But if you were somebody that did multiply, subtract, you could just do that 3 times. Multiply, subtract, again, multiply, subtract, again, multiply, subtract. First you would say 15% of 100 is $15. Take that away, I'm at 85. Then you do 20% of 85. Find what that is, subtract it. So 10% would be 8.5, so you take 17 away. And then you'd find 10% of that, and so on. Anyone want me to write that? Those little steps.
And there's a question like that.
There's a question like this on the homework. You want me to write out all those steps? I do.
Not the charge option.
The one before that. Business decisions. Okay. Last call. Anyone want me to write all those little 6 steps? Maybe I will after class. I'm going to leave room. Do it after class. If you wanted to do it without all those steps, then you could use the 1 plus trick again, because that lines everything up nice. Except it's actually a 1 minus trick now. So I could take my 100. I'm going to multiply it first by 1 minus 0.15. And then I'm going to multiply it by 1 minus 0.2. And then I'm going to multiply it by 1 minus 0.1. Whatever that is. $61.20. So this is why it might be worth looking at the 1 minus trick here, just because then you can do both problems efficiently. But on the other hand, on the final, you can pick to skip a lot of problems. This is one that lots of people skip, just because if you're doing it the 6-step way, it might not be worth your time. So the first of those things, as I warned you about, where if this is nice and easy, we'll looks like this makes sense if you practice it, then go ahead. This is a pretty easy one to do. If this is confusing, then probably stick with the ones you practiced more. Okay, the worst this could be is if what we don't know is something in the middle. So this is exactly the same thing we just did, except that we're pretending we don't know this number. And we're moving this over here. Oh, God. And so I'm just going to say that this whole 1 minus something I'll call y. And then what should I do? This is slightly confusing.
I would times all those that you have there, 100 times 0.5 times 0.8.
Yes, so that just turns into 68.
And then divide it by 61.20.
Almost.
So divide by
Divide it by the 68, because that's what stuck onto the y.
Oh, okay.
Oops, I should have done this one. Oh, okay. So, okay, and now this gets a little tricky again, because I don't want y, I want y to be 1 minus something. Okay? So 1 minus something is 0.9. Is that floating? Need the 90. Okay. So that means that this thing is 0.1. I could put a letter there if it helps instead of question marks. So 1 minus what is 0.9? 0.1.
So you're rounding up.
So a 10% sale, which is what we knew it was because we did the problem the other way first. This one is like the most skipped problem on the final. Just the amount of time it takes to do it. So if you like this one, it's not that hard, but it is very much its own kind of thing. Nothing else we do in classes like this. So. And that's everything there is about discount. So to summarize, at the very least, get used to the simple kind of discount. There's only one discount. Use 2 steps or use the 1 minus trick. That's an easy problem. It would be a shame to skip that one. Chain discounts, if you're up for lots of steps, you can. I'll write those in later. Or if you like the 1 minus trick, that makes this a very efficient problem. Missing link in the chain discount, then that becomes a bit more confusing. There's more opportunities there to mess up.
Probably makes sense.
But it makes sense. If it makes sense, go for it. It might be quicker than Sir Topham Hatt and the compound interest shenanigans. Okay, question?
Do the single equivalent discount rate, or are you using
Sure. More example problems are good. Okay, so she wants it to be 18. It's starting at 30. The first discount is a 10%. That means that at this point, there's 90% of that $30 still there. I don't even have to know what 90% of 30 is, I just know that. And then she wants another discount from the coupon, and we're not sure what that one is. With me so far? A little bit simpler because we just have 2 discounts instead of 3. So, same trick as before. We're going to make that whole parentheses thing, the 1 minus question mark, RY. 30 times 0.9 will be 27. Yep, my brain is not dead yet. Get the y by itself. The opposite of times 27 attached to y is divided by 27. So 66%. And that's rounding. And why is that floating? That makes no sense. Okay. Everyone with me so far? It might actually help to change that to a percent. Would that be easier to think about if we did percent right now? I bet it would. So let's do that. So you can do a riplop. We're going into percent. If I was on the previous slide, I would be saying that this is now 90%. That 90%. I think that's easier. Okay, back to this one. So, I'm doing pink, aren't I? So 1 minus something is a 66. We have 66% of the price left. How much did we get rid of?
Would we divide that by 30?
No, there's a subtraction happening.
Oh, okay.
So 100% minus what?
Yeah, this is 100%. No divided, just minus. I started with the whole amount, the 100% amount. I took away something, I have 66% left. So what percent did I take away? 30, yeah. I'm actually rounding badly here to make things worse. Oh well, I thought I was doing well.
Margin amount and mark amount and all those points are all the same thing.
Yeah, I can go over that.
Okay,
Okay, sorry I messed up with my rounding. Oh, questions about this one now? Does it make sense? Okay, so that is the end of the pricing. Let's go over things quick, just as sort of a whole review. By the way, everyone get the email about the table of contents? I hope that helps. I'm sorry if renumbering some of the homework random stuff was bad. Okay, so quickly what we did last week, we talked about wholesale cost and selling price, trying to be careful with our words, not just say the price of something. And the difference between the selling price and wholesale cost was called the margin amount. If you're thinking sort of looking down from the selling price down to the wholesale cost, that attitude says the gap is called the margin amount. And if you wanted to express it as a percent change, change divided by original, then the margin amount would be the change. The original is what you were selling it for to the customer. So as an example, if you had something that sells for 80, the wholesale is 60, the difference is 20, 20 divided by 80 gives you 25%. So that was one attitude of I'm looking down from the retail sale price to see how much more than the wholesale cost it is. The other attitude was markup. Now I'm starting at the lower amount, at the wholesale cost to the business, and I'm looking up towards what I'm selling it at. So that gap is exactly the same. The margin amount and the markup amount are the same in dollars. It's just sort of whether you're looking at it from the top of its head or the bottom of its feet. On the other hand, the percent change is different because what you're considering is your original has changed. So since it's change divided by original, now we're dividing by the wholesale cost. So since you're dividing the same dollar of change, no matter how you name it, by a different thing, you get a different percent. So the same dress, the same $20, the same 60 versus 80, it was a 25% margin rate, but a 33% markup rate. And if that's confusing, blame the retail industry. It's not the math people's fault. We're just doing percent change. So the chart we had was that there's the margin amount and the markup amount. And we're trying to be careful and say amount to mean dollars. And then there's the margin rate and the markup rate. And we're trying to be careful and use rate to say these are percents. And the amounts would be the same, just two different ways of looking at it. The rates, you get actually different numbers. Was that a good review? Questions on that? Then actually assigning prices to things. Oh, by the way, then there was a note that profit is different than margin or markup, however you call it. Because business has other overhead than just the wholesale cost of the good. So just because they earned $20 on something they sold you doesn't mean that that's all profit, because they have to pay the employee and everything else. So profit is different. But people are sloppy and talk about markup or margin as if they are profit. Okay, so if you're assigning prices to things, then just like we had the 2 steps for discount that you could make quicker with a 1 minus trick, you can do the same kind of thing. If you're subtracting things from the... Did I switch the order? Okay, so if I'm using markup, if I'm adding an amount to the wholesale, I can use the 1 plus trick. I could say that instead of doing 50 times 0.4 and adding it back on, which is great if that's how you like doing it, I can do 50 times the 1 plus 0.4 together, and when I multiply it by 1.4, I get the selling price without having to do an adding step. It's easier to just slam a 1 in front of a 0.4 than to add 2 bigger numbers. And then with the margin, it was the opposite. Like the discount, like things going on sale, we're looking down from a bigger amount. So instead of 1 plus, it's 1 minus. If you have a 40% margin rate, 1 minus 0.4 would be 0.6. Is that a typo? Yes, that's a typo. That's bad. One moment, let me fix my typo. There we go. So 1 minus 0.4 is 1 times 0.6, and then it's $30.
I missed a question like that. Do that last step.
I can even put that there if that helps. Okay. So margin pricing looks a lot like putting things on sale. So that's one reason people like margin, even if for some of our brains markup makes more sense.
It's the same thing.
It's the same kind of thing. Okay, and we talked about other things. This chart was the one Edwin asked about. We'll talk more after class if he wants. But when something is new, then the price, right, the up and down axis, is sold for is more than after time has gone on and it's old. So this is called the skim price. And the other one is the penetration price. Skimming is just skimming over the surface. Not everyone has the newest whatever phone yet. And the penetration is it's penetrated society. Everyone has one of these if they want one. We can't charge as much as before. Okay. There were also formulas for entree pricing. Should we do more examples of these?
Yeah.
Yeah? Okay. I unfortunately need to shrink it a little so they don't wrap too much. Let's... Okay, so restaurant meals are a special case, and they're mostly special because you usually don't sell your customer the thing that you pay attention to when you're costing it. No one gets an entire lasagna at the restaurant. They just get one plate. So at the very end, both of these formulas have divided by servings because we're asking what the cost per plate is on the menu. The first method for restaurant pricing is called the desired profit method because the restaurant knows what kind of profit they're looking for. And unlike some businesses, restaurants don't get a whole lot. This should be called desired markup method to fit the vocabulary we've just been using, but it's not. We're pretending that all the other costs are accurately there. I guess maybe they are if we did this right. Anyway, okay, so we have, in this example, $50 of food, $70 of labor, and $25. Yeah, I guess it is profit because all of the expenses are there. So more thorough than just margin or markup. We have other things like insurance and electricity and labor. So we're going to take that. We're going to multiply it by 10%. And we're going to do that with the 1 plus trick. We don't have to do it with the 1 plus trick, but if we were doing it in 2 steps, we need to do the 2 steps now before we divide by plates. And then we have it serves 6, so we're going to divide it by 6. So we get 140. You don't actually have to do this in more than 1 step. Your calculator.
Plus 25. So that'll throw off the answer.
What?
It's 25.
Oh, it's 25. I messed up. Okay. Typo. Like that. Okay. Time 26:58. Thank you. Okay, so it's more thorough than what we were doing before because it includes the costs other than the wholesale cost of the food. And we're dividing by 6 at the end because we're not giving someone a huge casserole dish or a pot of soup or whatever this is. So some restaurants do this. Other restaurants say that this is too much work. I just know that the food is 30% of my expenses. And it doesn't change that much from item to item. Whether my people are making fries or burgers or nuggets or whatever, the food is always about 30%. And the rest of it is salaries and insurance and electricity and rent and blah, blah, blah. So if you actually had that kind of business, then you can do less math. Then you can simply say that the food is 50. I don't care at all about the labor or the other things because they are built in to my number of saying food is 30%. That means those are the other 70%. Now, if I did this wrong and did a times 0.3, I would be shrinking that 50, right? 30% of 50 is a smaller number. So this is like the other times, like yield percent, where we're sort of working backwards. We're wanting to say that food is 30% of the total. What was the total? Since we're going backwards, we divide instead of multiply, just like with the yield percent. And then at the end, we still have 6 servings, so we're going to divide by 6. So 50 divided by 0.3, 27.78. The answers don't match because they're 2 different problems, right? These are 2 different restaurant philosophies applying to a somewhat similar meal. Okay, questions on either of those? Okay, lots of formulas. This is a little confusing just because you have all of these formulas that are a tiny bit similar and a tiny bit different, and the business world has decided to use too many words, margin and markup and profit, and they're all kind of similar and kind of not, and so on. Once you wrap your brain around it, it becomes pretty easy because each equation is pretty small. There's just too many things that are named too similar. Okay, that's completely different than what comes next. The next topic is the charge options. Let's imagine someone is buying furniture as the classic example, where the store gives you different kinds of ways to pay for this big purchase. The 4 ones you see most often are a layaway plan. The layaway plan is when you pay for the thing, sort of. You are going to say, I really want this dining room set. I don't have the money now, but I promise you I'm going to start paying off every month. And the store says, okay, we'll trust you. We'll put it in our warehouse instead of the showroom. And when you finally paid off the amount, then we'll give it to you. Sometimes there's 0 interest. Sometimes the store charges you a little bit of interest. And often they will charge you a little bit of a fee at the beginning just to cover their employees that are moving it from the showroom to the warehouse, because that costs them something. So this is nice for the store because they don't really have any risk. If you disappear and they never see you again, they still have the furniture. It's kind of nice for you because no one else is going to grab this thing you want and buy it, but it doesn't really help you at all because you still have to wait however many months before you get your thing. So, least risk, least reward. The second plan is the installment plan. You take the thing home, you pay a down payment. The down payment is partly because maybe you're just going to disappear or have your kids wreck it, or who knows what's going to happen. People do weird things. You're going to make your monthly payments. Eventually you've paid for this thing. So there's a small risk. Maybe the furniture will be damaged and you won't pay them any money. And there's a small reward for the store. They have some interest rate now. There's also the 0 down plan, where you take the item home and there's no down payment. And not only that, usually you don't pay anything for several months. These are for items that they're trying to attract you to their store, harder for the store to sell than the other things. And after that, you're going to pay every month to pay it off. Even though you haven't paid for the first 6 months or whatever, it's still earning interest. So by the time you start paying, it's a lot more costly than the other options. Then the final option is, well, let's ignore the store. Let's just open a new credit card and pay it off how we want. So that has the highest risk that the credit card company doesn't get the furniture if you go bankrupt. But it's also the highest reward for the credit card company. They charge higher interest rates than the furniture stores do in the other plans. And this is pretty straightforward. You set up the table, follow the example problems I'm about to show you. But there's no formula to it. So it's the opposite. Instead of all these formulas that are too much the same but small, there are tables that are huge, but it's pretty clear what's happening. So I'm actually going to skip away to this one. So Fendrick wants to buy a new dining room set for $900. He's looking at those 4 ways to pay that we just talked about. He can budget about $80 a month. This isn't completely fixed. If he has to scrounge up for a down payment, he can do that. But he likes $80 a month. So which of these plans are best for him? And there's so many numbers that we're just going to look at a Google spreadsheet. No, I want to make it bigger. I don't want to. Okay. So on the layaway plan, can I look at more of the screen right here? How do I hide that menu there? Okay, good. On the layaway plan, he owes $900. He pays $80. Every month, how much there's left goes down by $80. And the store is nice and has no interest. But they do charge him a $50 storage fee to get things in and out of the warehouse. So overall, he will pay all $900, and we'll pay $50 more. Oh. That one's pretty trivial. The installment plan. You've seen this type of table earlier in the things we did with interest, so there's nothing really new here. He's starting this time at $800 because he had a $100 down payment. He pays off, the store says $73, they get to pick. Subtract, find how much the interest is now due on, because he's not paying interest on $800, just on the $800 minus the $73. The interest rate was 1.25%. It was something bigger, but we divided by 12. And so that's the amount. Add it back on. That's what we start at the next time. we keep going. We've seen these tables before. When you add up the interest, it's 54.33, and this should actually be 9 because we had the $100 down payment. So it's a little bit more expensive, just a few bucks. The zero down plan, by the time he starts paying off his payments, then it's up to 984. So all that interest is building up the first few months. The store this time says he has to pay off 180 each time. That are just about 80 a month, like he's wanting. It's deals. So interest is huge, over $100 of interest when you add this. And finally, the credit card. This looks exactly like what we did when we talked about credit cards with compound interest. You start in with all 900% down payment. He gets to pick 80. Subtract to find what the interest is due on. It's a higher interest rate because it's a credit card. He pays less than 100 of interest. More than that $50 storage fee, but he gets his thing right away. So we can do certainly more of these on Thursday, but I'm going to skip ahead because this is review. You've done these kinds of tables before. What I do want to show you, I am remembering, is that when you go to the practice final, then this isn't as hard as it looks. How do I find this number here? Yeah, it's the same as that number there. I don't have to do any math at all. And how do I find this number here? It's the same as that one, right? How do you find this number here? You're making it harder than it is.
Oh, like how much the interest?
The interest is due on that amount. You don't pay interest on all 4572, just a bunch of it. Yeah. So whatever this green number is, I'm going to subtract 840. And that's the same for here. That's going to be that one. And then this number, normally you would need to do the the blue number, then multiply it by an interest rate and get the interest. But because we've given you this number in advance, then I can just say that I'm going to subtract. However much the ending amount is bigger than what the interest is due on, that must be the interest. Okay? And that, let me pick a new colored. So this number here is bigger than this number by the 20. So what looks like a hard problem on the test is actually just 4 subtraction problems. 2 of them for blue and 2 of them for orange. And sure.
On number 2, so the grade is carried over from the top one. And then you subtract that from the 840 and come up with that.
Mm-hmm.
And then over there where you said red, how do you know what to, you're saying subtract, but how do you come up with the interest on number 2?
So let's look at row number 1. If I had 378798, and I subtract away that one, that's going to give me the 5598. It's how much we get bigger by adding on the interest. And this is just an unfortunate thing of having a timed final exam. I would love to be able to say, help Fendrick make out one of the big tables like you saw before, but I just don't have time in a 90-minute test. So instead, I can test, do you understand how these tables work and the flow of things, but I only have time to give you addition and subtraction. Sure. I will certainly test you with multiplying and interest rates and so on and other problems. We have lots of compound interest problems. I just don't work them into the table because everyone would skip that. And that's really all there is to charge options. It's the same kind of tables you've been using in compound interest before, but slight variations on them. Is there a down payment? Do we start paying off things right away? Do we charge you for storing things? So, annoying real-life complications to compound interest. Okay, so that's that. Let's go back out here. So in a perfect world, I would encourage you all to do lots of charge options homework, but to just get the final exam question right, you don't need to know all this stuff. Okay, then our last topic is the likelihood. So everyone come get a spinner and get a blank piece of paper. The goal of our likelihood section is to understand a kind of traditional complicated grading scheme. So we will get there. It's not too tricky. And we get to play with toys. So if you have a piece of blank paper, you can put your spinner on top. I'm going to try and do it on the board here, but of course, mine is too small. So this is a fair game. I can put my spinner on, spin it. Does it land on the +1 or the -1 side? Everyone's happy that that is fair. Your question is, first, now we're changing the game. If you win, you get $2. If you lose, you only lose $1. How do you make that so it's a fair game, and if you were to play it a lot, on average you'd come out even? It doesn't work to draw the line right down the middle anymore. Then you would come out ahead, because you'd be earning $2 more often than you lose the $1. So where are we going to put the line instead? Third. Anyone want to come up and draw their lines? You can test it out on your paper if you want. We could make it something like that, where the +2 is much bigger than the -1. But that's just going to make it worse. Then whoever plays this game will earn a lot more. So that's not right.
I would go straight down to the dot.
You're welcome.
Do this straight down and then this way.
Okay. I'm going to draw a dotted line here. Try and make it thirds. Okay. I've heard two people now talk about thirds. She drew thirds, Edwin called out thirds. So Amicha and Edwin, right? So 1/3 of the time, you're going to get $2 ahead. 2/3 of the time, you're going to lose $1. So overall, it's going to work. You're going to go, if each third happens equally likely, then you'll get +2, -1, -1, +2, -1, -1. You'll come out even. Everyone okay with that answer? Okay, let's make it even harder. Okay, now it's +3 and -1. Who wants to come draw where the lines are?
What if we did a 6?
What if we did it 6? Why would it be 6? Tell me.
Well, I just think about we have to, in order for it to be fair, you have to compensate for the -1. So, what I'm thinking is that you have to half that 3, right?
Almost. You're on the right track. Here we had to have 2 copies of the -1 to balance out the +2. So how many copies of the -1 do we need this time?
We just add another.
Yeah. So we're going to look like... Oh, my artwork is too... So... we have 1, 2, 3 ways to get -1, 1 way to get +3, and it'll work out.
Okay, I was putting, and then I was adding another dotted line on the other side. Okay.
Makes sense now that you see it?
Yeah.
Okay, I'm not going to ask you these on the test, but it's a good way to help thinking about this thing. If I want to be fair, the things that are worth more have to happen less. That's what you're supposed to be getting at. Okay, let's move on. If you want a real challenge, then before Thursday, try this one. And we'll go over it Thursday. But that's a good one to rack your brain. Okay, more jargon. So probability is a little bigger. Is a ratio, and we've done lots with ratios. And the two things we're comparing are the outcomes we like, our desirable outcomes, and the total outcomes. And probability is often written in percent format instead of looking like a fraction. The kind of probability that we're doing is just counting. So we can look at a table like this of dice values and say, at the bottom here, when rolling 2 dice, what's the probability of the sum being even? 7. I'm sorry, being 7. So we want the ones we care about for whatever reason over the total. So how many ways are there to make 7? 6, right? The 6 green numbers. How many numbers total on the chart? Yeah. 16. My brain, I knew my brain was not reliable today. Oh, okay. So I'm just making a ratio. The thing on top is the ones I like. The thing on the bottom is how many total possibilities there are. And I probably am asked to write it as a percentage. I could make this 17% if I want, but in this case it really is as accurate as I would want. How about probability for it being 10? We still have the ones we want over total. How many ways to make 10? 3, the pink ones. There's where I had my 12 in my brain. Okay. I'm not rounding it. Okay. Again, I don't really care how you round it. You can call it 8. So that's probability. This is pretty nice. All I have to do is write one number on top of another. It just takes some counting to get what the top number is. Let's make it a little trickier. Imagine there's a gumball machine. There's red, green, and blue gumballs, and there's equal amounts. Here's all the ways to get out 3 gumballs. How likely is it to get at least one blue gumball? So how many things are on the chart total for the denominator? 1, 2, 3, 4, 5, 6, 7, 8, 9 times 3 is 27. How many of them have at least one blue? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 19 out of 27. Makes sense. Okay, so probability isn't bad. Counting is annoying, but we can live with it. Just to be confusing, there's also the word odds. The odds of an event are again a ratio, but we're changing the denominator. Now, the one on top stays the things we care about, and we're changing the denominator to the ones we don't want. So if we go back to this picture, now if I want odds, there were 6 ways to make 7, but I'm not going to put it over 36 anymore. Instead, how many ways are there to not get 7? 30, right? Take the 36, get rid of these 6, and there's 30. Odds, we tend to not ever make it into a percentage, and we usually write it with a colon instead, or the word 2. One of the few cases where outside of the SAT, people actually write ratios other than fractions. If we did the odds for the 10, then it would be 3 on top, and how many on the bottom? Yeah. Odds for 7. We did this. Odds for 10. So that's pretty easy too. Counting might be annoying, but there's nothing hard happening. on your test, now you can say, oh, look, here's one of these dice charts with nothing shaded in. And it's going to ask you to find a probability, and it's going to ask you to find an odds. It might try and trick you and say, like, 3 or more for the sum. So you have to count the 3's and everything else. But 9 or more, 10 or more. So let's do this. 10 or more, that would be these ones. So what's the probability? What's our numerator? How many of them do we like? None. 1, 2, 3, 4, 5, 6. So 6 over 36. And that's again going to be about 17%. And then the odds would be 6 of them, not over 36 anymore, but take away from 36 these 6, and we have 30. So any of those. So this is usually good news. These are quick, easy ones to get right on the final.
So the probability is whatever is highlighted divided by the whole amount.
Mm-hmm.
And the odd is
The highlighted divided by the unhighlighted.
And then you take that away from the 36 thing.
Right. If I was to say, where's this 30, it's this other part. Right. That's where the 30 is coming from. Okay. The absolute change and relative change is an important one for real life to understand news reports and things, but we don't have time for it right now. And weighted average will be our very last subtopic. And this is where you can actually say, oh, here's how my grades are scored. If I didn't know what a grade was, what do I need to get a certain percentage overall in a class? So we'll do that when I see you Thursday. But again, Thursday, bring questions. Start your big problems if you haven't yet, so you can get feedback on them. If you need to borrow a book for the book report now, do that before you leave. All of that.